Hello, class. Yep, this is our first lab, and I thought, this being the first lab, there may be some problems that occur in us doing the lab, but we'll have to see how that works out. All right. This first lab is actually to use some software online called Multisim. Right, it's out of multisim.com. And it's something that you may have historically thought was PSpice, right? I think it originally came out in a PSpice flavor. It was a standalone software application program, whatever you wanted to call it at the time. And I think that there's still a standalone desktop thing for it. But I do know that at Wentworth, we have, I could open this window a little bit since I'm just talking to you and I'm not staring at the thing. Whew! Now that's too much light. Anyway, well now this, I don't know. I'll go with that because then I can actually see my face without being blinded by the light of these three, windows I've got looking on the ocean. So, what I wanted to do today, this does not look right, does it? And it's backwards, so I was pulling down the wrong one anyway. Okay, that looks a little better. I don't think it's a mirror image. I think it's an actual image. So, having said all that, I'm going to introduce you, and you may have already used this software before. I'm going to introduce you to some simulation software, and I've been working on this to bring up this screen. So I'm going to share a screen with you. There we go. So I hope that all of you can see my little picture in the upper right-hand corner. I don't know where it appears on your screen, but this is the screen that I'm sharing with you, and it's on Firefox. So actually you can see all the various different things I've got up there. Yes, I do follow COVID and all of the other intelligence websites that are up there. I'm a very active person. I don't know, maybe there's a way to put that down, but that's not what's important. What is important is I'm going to go to my login, and I hope that my password doesn't jump up there. There's my email, and of course I've got my password. Uses cookies. I never accept those cookies, really. I just log in. I have a computer that doesn't accept cookies. So this shows you, I've got 3 circuits in there. I just actually started the thing. My name is actually Gandalf 0001, which is all over the internet for other things too, but that's not the username I usually use. And these are my 3 latest circuits. Now I put some circuits up there. I'm not going to view those circuits. You'll be doing circuits yourself. What we want is, now that I'm logged in, and when you first come to this site, you should have a license already allocated to you via your, I hope I'm recording this, via your enrollment at Wentworth and your email address. I was just thinking of 6 things at the same time. However, so you'll have to register. I mean, you go into registration. I'm not going to go through that whole process because then that would require me like putting in my password and stuff. So I'm going to assume that you guys, being college students, will be able to, and with Wentworth, and we've paid the licensing fees, that you should be able to get into multisim.com and create your free account, and then you'll get to this point that I'm at right now. Right, if you have problems with this, and I'm going to try and check this out with DTS at Wentworth to make absolutely sure that not only the faculty but all of the students, and I'm sure that that's the case, have access to Multisim so that you can do simulation. So let's create a circuit. So I'm going to click on Create a Circuit. This is initializing Multisim, and that's what it's done. It's put up a Multisim pad, if you want, that we are going to use now with these drawing tools over here. We're going to use these to create a circuit. Let's just create a very simple circuit right off the bat. Well, what do we need to create a circuit? Well, the first thing we need a power supply, right? So I go over here to the power supply or the sources that I can get. I can get an AC voltage, that's for network theory 2, AC current, network theory 2, clock voltage, digital electronics 1, clock current, digital electronics 1, triangular voltage. You know, I'm not really sure where we'd use that except in op amps, your analog circuits. You could put a triangular voltage in and either differentiate that voltage or integrate that voltage. All right. Here's where we are though, DC voltage and DC current sources. So let's put a DC voltage source in there. And I like to put my voltage sources over on the left. You can see now that, let me just get a sip of water, because unlike real classes where I actually get to, you know, quench my thirst in between saying things all the time, that's not true with online courses. Delicious water. Now, we've got several things. This could rotate the source. See how I'm rotating the source here so that the positive would rotate around? This gets rid of that as if we didn't want it. This copies that. And then this, I really have no idea. Oh, flips it. So it flips it around its y-axis, I believe. And obviously for this, that wouldn't do anything, because it's asymmetrical about that. All right, well, let's click off that now. So we've got that, and it starts with 12 volts. Maybe we don't want it to have 12 volts. Well, let's just wait a while. I want to show you, you know, how to put these together and everything too, so that you can do it relatively fast. Now, how? Let's put a resistor in, because that's where we really are at this point in time. And I'll put the resistor up there. Do I want another one of those horizontal resistors? Sure, let's put another one there. You know, do I not want another one? Sure, I'll put another one there. Okay. Maybe we want some other resistors. I'm just going to click this. But instead of having it there, maybe we want it to be here, but we want it to be vertical. Well, I click it in there. I just click this, since it doesn't matter which end of the resistor you go to, like unlike an electrolytic capacitor. If I was to put an electrolytic capacitor in there, there is a pathway that the current has to flow through an electrolytic capacitor. But as far as the resistor goes, there really is no direction, right? Now, let's say that I want another vertical resistor. I'm going to put another vertical resistor in right there. And, you know, okay, so we got a couple vertical resistors. And, you know, do I need another one? Let's put another one in series with this one down here. Boy, it's starting to look pretty complicated, isn't it? I'll put another one in series with that over there. Do we want to put some down on the bottom? You know, I could put one over here, so let's click on that. Let's put another resistor over here. Boy, it's becoming a little complicated now. I don't need another one in series with that. But I may need a resistor. Let's just put one here, right between these two. So I want to rotate it, right? And in fact, you know, it's a bit low. It's one line low. So let's actually bring that up. Why can't I bring it up? Come on. There we go. So now I'm going to bring it up so that it's in line with that. Okay, I click off there. You know, the things here are pretty large, but we can still see what we have. I could actually, you know, why don't I just move this one down a little bit. Let's move that one down to here. I'll move this one. Oops, I'm moving everything now because I've clicked them together. Let's just move this one all by itself down to here. We want to give ourselves a little more room, so I'm going to grab that one and, oops, I think I went down one. I'm going to move that one down here, and since this one is in series with that, why don't we move that one right underneath it? Does everyone see how I'm manipulating the various, well, these are all resistors, but the various different components that I have in my circle so that I can sort of spread it out a little bit. You're probably saying, hey, none of these things are wired together. That's right. You know, just to make it look symmetrical, let's bring that one up there. I see that I accidentally brought this one up with it, so I'm going to move that one back down. Let's put the whole circuit sort of in the picture now. Excuse me, I did a lot of lecturing, online lecturing yesterday. So my my voice is a little strained, but I'm trying to get up as many things so that we really have the whole, not the whole course, but vast majority of the course organized by the end. Okay, these are just random resistors that I've thrown up in there. And let's connect these. So now I come up here and you see that I've got that spool of wire, how it's now turned into a spool of wire. I just realized I forgot to turn my timer on, and you know, with the lab, it just could go on forever. So I'm gonna say that I've been on here for about 10 minutes. Let's just make sure that I don't go over the maximum megabytes that YouTube, you know, has. So let's do a little wiring now. So we wired those two up. And then we're going to wire these up. So I want to wire, I'm just going to wire across here. You know, I want to connect the top of this to that wire. So I go up there, you see how it's making those zeros, those wavy encirclement graphics. I click on that, and then I've tied myself into that wire. See how easy this is? And I'm just going to go down here and click on this. So I've tied that in. I'm now tying this, and I click on it. Then it spools out the wire. I get it to look at the wire. I click on it once, and then I just move. I don't have to hold the clicker down. You can. I don't think it really makes a difference, though. And then I click on this. I bring the wire down. Oops. And then I bring it over to, why is it doing that? Well, whatever. We'll go that way. I don't know what this is. Can I clear that? Yes, good. All right, yeah, somebody obviously at Multisim wants to talk to me about something. You know, sell me something, obviously, is what it is. But Wentworth has already paid for this as far as I know. So does everyone see how I am now just completing this circuit? And this is just a random circuit that I threw up there. And we're going to probably want to always click on this first because it doesn't know where you're going, right? So if you click on the component and then get to another place that it can connect to, it does. And you see I've left a lot of room in here too, so that I can put other things in there, sensors that are going to find out what the current and voltage are at different points. Now, I like to use, when I go into the analysis and annotation, you can use a voltmeter, a current meter, or a voltage and current meter, right? Now, it doesn't mean a lot if you don't put a ground someplace in the circuit. So the first thing I want to do is I want to go over here, and I'm going to put a voltmeter and an ammeter in there. God, I should probably, can I change that? Why don't I put that down here, because it'll be exactly the same, voltmeter and ammeter. So I'm going to keep that there. And when I run the simulation, it'll be in there. Now, we want to change a couple things. Instead of this being, so I'm going to just click on that. Now I'm going to double click on that. Does everyone see what I did? When I double clicked on that, it brought up, I'm going to have to move my Maybe that's just my own thing. I don't know if you guys have the small picture of me talking in the background, but if you do, that's great. Now, we don't want this to be 12 volts. We want the magnitude to be 100 volts. So I'm just going to change that. And then we could click on this and send it back in, right? And then you see that it's changed from 12 volts to 100 volts. We're still calling it V1 because it is the only voltage in here. But let's change some of these. So let's just go click on R1, right? And we see that it's named R1. That's fine. It's given all of these various different number names as we put the resistors in. But let's change that now to a more realistic resistance. And I'll say that's 330 ohms, right? See, we've got ohms at the end here. And then I don't have to click this going back in. I could just click on this. This just shows me, you know, background stuff and everything else about the circuit. And then I could go and click on the next resistor. And so when I click on the next resistor, it brings it up, R2. I'm going to say that resistor is 390 ohms. And again, I'm done. Or I could just go and I could click on the next resistor, which is this resistor here, R3. That just pops up. It allows me to immediately change that. Again, I'm going to change that to 120 ohms. Just pulling these numbers out of my head. I click on the resistor again, brings this up. I'll make that 180 ohms. I've got, yeah, I did R8, but I'm doing R5 now. These are 2 in a row, so I'm going to make them relatively small resistance. So I'll say that that's 100 ohms. And then I'll click on R7. Let's make R7 a little larger. Let's say that that's 220 ohms, right? We've got R9. I click on that. Again, I'm just putting these up here. Now I'm going to give that a little larger. That's going to be 560 ohms that we have there. That's going to sort of cut down on the current because, as you know, the higher the resistance, Ohm's law, the smaller the current, right? So then we'll go over to R6. Again, like I say, just putting these in here. This again is going to be a relatively small resistance. I'll say that's 68 ohms. All right. And this one, let's say it's 82 ohms. All right. So you can see that I've now gone around. I'm just going to slide that circuit back in. I've put in resistor values now. And is this a relatively complicated circuit? Well, yes. Yes, it is. You know, we want to find the volts and amps here because that'll tell us how much amperage is coming out of the power supply and then flowing into this resistor network that we have over to the right. Does everyone see that? And so this really lab 0 is for you to play around with this new fantastic and powerful tool of the simulator, the Multisim simulator, that you'll have to help you with your experiments and also with your homework and everything else, and understanding how current and voltage and Ohm's law and the power law all come into play throughout here. So, you know what I'm going to do? I'm going to move that up to, you know, just so that, because the way that I draw and figure out current and everything is out of the positive end. Now, this is 100 volts, and these are relatively low, so we're going to see some large amperage through here. I'm not sure what this 4 is doing. Oh, is that a node? Yep, so that's node 2. This is node 4. This is node 5. This is node 6. And you can see all the nodes are short-circuited together. So this node 7 right here, what I'm going to do is I'm going to go over and I'm going to get a ground, right? Because we've got to have a reference voltage in our circuit someplace. So I want to put a ground down here. And when I move the ground down, now look at, you've got to make sure that you see that see how it's got the circles around. It says, I am connected to this place, this node. And I click, left click on that, pow, it's there, it's connected. Now, when I do simulate the circuit's going to know that this node right here, and that's quite a large node, isn't it, is going to have the same thing. Now this node here is going to have the same voltage as this node, right? Which is ground. I shouldn't say it's the same voltage. This is going to have 100 volts. It's going to be relative to this, but it's going to have the same current that's flowing through into here. So I want to show you, I want to do two things. Let's put one of these, let's use both of them, voltage and current. So let's put one here, right? That's for voltage and current. It'll measure the voltage and current there. And we know that we've got another, right here, we've got the same voltage, don't we? But do we have the same current? I'm going to tell you right now, the answer is no. No, we don't have the same current because we have, if you can see, the current that's coming through here. So what I'm going to do is I'm going to put a volt and ammeter right at this point. I want to find out what the voltage is at that point anyway. And why would I? Because I've got a resistor here and a resistor here. So there's a voltage drop here, voltage drop here. I don't know how large that voltage drop is going to be. And so what I want to do is I want to put another one here as well, right? So I'm going to click that in there, and we'll find the voltage and the amps across there. How about up here at 5? There's a resistor there and a resistor there. So we know that we're going to have a voltage there that's going to be non-zero. How about down here? So at each of these nodes, I really want to find out what the current is. And then if you look at the arrow, you can see what the arrow is, the direction of positivity of the volts and of the amps. Now I'm going to go over here too, because this is going to be the same amperage as that, but it's going to be a different voltage, right? Okay, and then up here, I want to find out, you can see that we're going to have the same voltage here as we would have over here, but a different amperage. So we can really use this to find how the current is flowing. Now the current that's here and the current that's here are going to be the same, but then the voltage is going to be different. So I'm going to put a volt ammeter there. I think I've got them just about every place that I can see there's going to be a different amperage or a different voltage compared to the one next to them. So let's stop the circuit right there. Excuse me, I'm just going to move this in so that we have a little more room to see the circuit as we simulate it. Now we've done all this. We've put this circuit together. We've now got our volts and ammeters all over the place in the circuit, right? So what I want to do is go up here. I'm just going to stop on that, and it says Run Simulation, Control R. I could have just hit Control R, but I wanted to go up there to that play button, and I wanted to hit Run Simulation. Oh, excuse me. So now, let's run the simulation. And there you go. As you can see, or at least I hope you can see, because I am, it says you are screen sharing, and everybody should see this right now. You can see what the voltage is. Yep, we would expect the voltage coming out of the power supply to be 100 volts. And you can see that the arrow here is pointing back into, I wonder if I could change that arrow. No, not really. No, I don't think I can. So we can see that it's minus 216.42 milliamps. Does everyone see that? I'm going to have to play this back to find out if this actually is working the way that I think it is, but I do believe it is. And so, so it's minus 216.42 milliamps, and that's saying really that it's positive. If we were to, look at it going up this way, we would see that we've got a positive current flowing out of that DC power supply, and it's positive 216.42. It just so happens that the arrow is pointing in the opposite direction, and I'm not sure how I could get that arrow to point in the positive in the upper direction. There's got to be a way, but I haven't figured it out yet. I'm sure that you students have more time than I do to do that. But whatever, we've got 216. We know that since the arrow's pointing in that direction and it's a negative, that really the current is going in the opposite direction. So we got 216.42 milliamps flowing out of this. And then it's flowing into resistor R1. Well, what's going to be the voltage drop across resistor R1? It's going to be, Ohm's law says V equals IR, right? V equals IR. So V equals IR, and R is 330. I couldn't see it behind the thing down there, is 330 ohms. Then, get back on screen. 330 ohms times 216.42 milliamps. Let's just punch that into the calculator since I plucked these out of nowhere. So I've got 0.21642. This is how you're going to do it too. Times 330 ohms, and that gives me 71.4. 71.4. So I have a voltage drop of 71.4. So 100 minus 71.4 should give me a voltage of 28.6. What do you know? 28.6 volts. 216.42 milliamps. So as you can see, the current at this point right here still is 216.42 milliamps, right? But you can see at this node, using Kirchhoff's current law, we've got to separate. Part of the current is going to be going this way, and in fact, we see from our simulation 190.55 milliamps is going in the direction of this next node, right? Because this node is bifurcating. So of the 216.42, 190.5 is going forward. How much is going down? Right? This obviously cannot be correct, because how can that be 190.55? Something's wrong there. I'm going to move that up a little bit. Here, why don't I, oh, I've got to stop it. Good, now you're learning, right? You have to stop the simulation to move things. So this thing right here, the 190.55, that obviously is a mistake. I'm just going to move it up a little more. It can't obviously have 190.55 going that way and 190.55 going this way. So let me click on that. And that says 12.95 and 12.518. So there was a problem. I had it too close to this resistor, and it was actually giving me the current down here rather than the current up there. I'm so glad that that happened, right? Because you can see that if I accidentally move this, let's go up to that thing. If I accidentally move this down and it's touching that resistor, it's going to say 195. So make sure that it's on the wire. I'm just going to move it up just a dash onto that, just into the next thing. Now you can see that there's a little pink here and a little pink up there or whatever for the line. I call it pink. Probably there's somebody saying that's more like a burgundy. You know, that would be somebody who could differentiate colors better than I can. I think it's sort of red. And you can see now it still is saying 190.55. So let's bring it up one more. Come on. There we go. And now you can see that it's really 12.518 and 12.95 volts. This down here is 0 volts, but 12, let's see if that's 12. Well, that can't be right either. Let's run it again. Let's do the simulation, see if we still get that. So 12.518, well, where's the current going? I've got 216.42. I see here, I've got 190.55. I'm pretty sure that 190.55 and 12.5 is not correct. So that is, that obviously is not correct, because 216, I mean, where did the other current go? The other current has to be either going this way. I'm just going to move this back. Now, this is something that oh, I'm sorry. I have to stop it. But, it's just odd. Sometimes you have to run this a couple times. Now, that can't possibly be right, because 12.518 and 25.87 is certainly not going to add up to 216 milliamps, is it? So something, because we know at this node, Kirchhoff's voltage law tells us that that has to be 216.42 milliamps, and it's got to break up into these two things. In fact, I'm sort of happy that this happened. Let me sort of extend. What I want to do is I want to just extend this. I'm going to hold the controller. I want to see if this works anyway. I want to gang these together, and then I want to move those. Oops, wait. Move those. Where? I want to move those up. So how do I do that? Oh, I have to stop it. I'm sorry. So I want to move. Oops, wait a second. Could not move all objects in defined section. Well, that's odd, but I'm learning here. In many ways, the same as you. Let's see. Do I have to do that one too? I probably do. I probably have to do those. And then what I want to do is I want to move all of those up. And obviously it won't let me do that. So let's see if I can move that up. Yeah, that's pretty good. And then I can move that up. And let's move that up. Let's see if I can move the rest of these up to give me a little more room to see the various. Oops, no, that doesn't seem to be going well. Let's get rid of that. And then I think this might have to be moved up there, and then hopefully we can move that. No. Why is it trying to? There we go. All right, I want to move. Oh, just that. Well, that's not going to work, obviously. But don't see that should have caused any problems either. So why don't I run this and just see what's going on now? Because in some ways, it was good that didn't work out, right? Because we want to see this, right? So 216 milliamps is going there. Let's move this. Oops, sorry, got to stop the simulation. Let's move these that have been lost back up to their rightful locations. All right, that's there. Oops. That one is moved back there. It gives me a little more room to move these so that we can see them as well. Okay, so let's run our simulation. This one was still off, so I'll stop the simulation. And start it up again. See, really, this is just me trying to give you a tutorial to how to use this incredibly powerful software. I just want to see if all of these came up. They did. Now let's see if any of them are actually correct. Still, 25.87 milliamps. That can't be right. And this down here being 12.58 milliamps, well, that can't be right either. So let's stop the simulation. That's why I wanted to disconnect this and really connect. No, not that. Let's delete this. We'll leave that there, and then I'm just going to tie this back into there. Right, so it's all a continuous circuit. That's a continuous circuit. This is a continuous circuit. And run the simulation, and hopefully it will come out right this time. Still getting, oops, wait a second. I guess I've been on here. Labs go much faster. Let's just stop this, and let's bring this up to here. And let's try it again. All right. Now, 190, 25.87, that is 216 milliamps. I think everybody can see that. So this had been placed in the wrong place. Be very careful with that. And this is where your engineering fundamentals knowledge comes in, because we know this is 216.42, right? We know that these two, that coming out of here and this going down here, have to add up to 216.42. Does 25.87 and 195 add up to that? Yes. How about here? Now we're coming in here. We've got 25.87. 12.58 is going down. 13.52 is going along. Is it still 13.52? Is it still 13.352? Yes. Now these have to combine again. So we've got 12.5 and the 13.352 combining. Is it the 25.87 that originally went into that part of the network, resistor network? Yes. And then how about over here? We're still at 25, right? But we've gone across this. So instead of 14.48 volts like we had here, we've now lost the voltage across that 560 ohm resistor. We're now down to 0, but we've still got minus 25.86. In other words, it's flowing, the current is flowing against the two arrows that we have here. I wish I could turn those arrows around. But they're always looking in that direction, right, for positive. So we know what the positive direction is. So, and then here, we've got the 0 volts, but all of a sudden the 190.55 milliamps is coming back in to add to the 25.87 and pow back in there. All right, I'm gonna stop the simulation there. What I want you to do for lab 1 is I want you to put together a circuit that works, and troubleshoot that. Just like I had a problem, you know, with this circuit, use your knowledge of Kirchhoff's current and voltage laws from chapters 1 and 2 and everything to put a circuit together like this so that you can do it, right? So this is going to really be, I think this is lab 2. Lab 1, I think I'm going to make on dimensions and units, which is a great lab 2, and we'll do that as sort of a very easy take-home lab, but I'll also point out to people early on in the course about Multisim and that you should get your things set up with Multisim, because this is going to be lab 2. You're going to make a circuit on Multisim, and you're going to make sure it works, and you're going to send it in to me. And then you won't be able to maybe analyze how all of the current drops across the resistors go and everything, but you do know your fundamentals. All right, got to get off here because we've taken too much time already. I'm going to stop sharing this. Back here, I'm going to stop the recording. Wasn't even sure I was